merge two sorted arrays. So that's the goal, to merge two sorted arrays. And I'm going to start from the top, explain my rationale, and give some testing to see if it actually works. So before I start, here is the objective. We have two arrays. So we have array 1, array 2, and they're both sorted. So array 1 has values like, we'll go 2, 4, 6, 8, 10. Those are the values for array 1. And then array 2 has values of 1, 3, 5, 7, 9. Let's see some of the attributes to these arrays. They both have size and length of 5. So array 1 size and length is 5. And array 2 size and length is 5 as well. So the objective for this function, merge two sorted arrays, we see that they're both sorted arrays. We want to merge them into one. So when we say merge, we want to keep them sorted. So that's the key to this function. So the size and the length of before we even talk about the size and the length, let's actually mock out what array 3 would look like based off of array 1 and 2. And we know that array 3 equals 1 and 2. So array 3, it would look like this. It would go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so what's the size and the length of array 3? Well, we're merging these two together, so it would be 5 plus 5, so that would be 10. Now that we know what our objective is, let's look at the actual source code. So for starters, our goal is to sort two sorted arrays and place them in a third array like we talked about. The third array will be given back to the user as a pointer. When we create dynamic memory, it returns back a memory address, which will be array 3. There's already a structure that's been created, an array structure, and that pointer is going to be created in that array structure, and we're going to name this function merge two sorted arrays. This particular function is going to take in two parameters. First step is we want to create a third array dynamically where array 1 and 2 will be merged. So what's the size of this third array? Well, the size of this third array is going to be array 1 plus array 2, which means the size is going to be 10. We can also say that the size of array 3 is basically the length of array 1 plus the length of array 2. And I just want to preface, length and size are different, right? If we had a value can go in there, but there is no value, then in this case, array 1, the size would be 6 and the length would be 5, if that makes sense. But in this case, they're both 5. We're going to create a pointer, an array structure pointer, and name it array 3. The reason why we're going to create pointer is because we're dynamically allocating memory from the heap. So we're going to do new array structure, and the size of the array structure is going to be the length of array 1 plus the length of array 2. That will give us a sufficient array size for our new array. Now that we have 3 arrays, we have 1, 2, and 3. The goal is to add up arrays 1 and 2 and place them in 3. And for that, with the third array created, now what we want to do is we want to set 3 indexes, which will represent all 3 arrays, I, J, and C respectively. Those 3 are arbitrary letters. I just prefer those. I is going to represent array 1. J is going to represent array 2, and C is going to represent array 3. These 3 indexes are very important. So basically how we want to do it is we want to compare, and I'll get back to that here as well. But basically we want to compare the elements in arrays 1 and 2. So we're going to be comparing I and J, and we're going to be moving I and J along both of the arrays lengths. So we're going to go from I to the length of the array. While we're traversing through both arrays, we want to do a comparison in whichever whichever value inside of that array is lower, we want to put it in array 3, and then we want to continue to advance array 3 and subsequently the one that we just passed into. Let's look at that a little further. So we want to compare the elements of array 1 with array 2. like we spoke about. And whichever element is left, we want to store that element inside of array 3. That's 1. And then we want to move the index to the right. So plus 1. And we know that we're going to be going from 0 to, at here I said length minus 1, but it's really length. Let's look at the while loop. So while I is less than its length, and we know that the length is 5, while I is less than length of 5, and remember I represents array 1, and J is less than the length of array 2, which is also 5. So both of these have to be true. Both of these have to be false in order to get kicked out of the while loop. So the while loop states that while the index, which starts at 0, we initialize all 3 of our indexes to 0. While they're at 0 and they're still less than the length, which is 5 for both of them, that's when we want to enter this while loop. So let's talk about the logic in this while loop. Let's start here. So first thing, we want to create an if statement within this while loop that compares the elements at index I, which is array 1, index J, which is array 2. And if the value is lower in whichever one, we want to place the element of that part, in this case I. So let's start with I. And if the value of I is lower, we want to place the element within at the index of I inside of array 3 at index C. Array 3 or index C represents array 3, which is for the third array. Yep. So let's check out this if statement. So if, and A represents array, by the way, A represents array. So if the array, which is array 1, I, so we know I is 0. So the element at index 0 for array 1, if that is less than the element at array, and J starts out at 0, if the element at index 1, if the element in index 0 at array 1 is less than the element at index 0 at array 2, then and only then do we want to place the value that of the lower element, which is element I, and we want to actually place that into the index. We want to place that at in C, or the index of C, because remember, we're also going to, and we're going to see it right here, once this occurs, we're going to increment both third array and the array that we just pulled from. So in this case, we're pulling from array 1, which is represented in I. So since we're pulling from array 1, we're going to increment that index to the next index over. Also, because we're inserting into array 3 now, we also want to increment array C as array 3 as well. And we can also do, I can do C++ here, but I just chose to do it right here. So go to the next element for each index I, which represents array 1, and index C, which in array 3. Okay. And we're still in the while loop now. We're still in the while loop. So if, however, let's say I isn't in fact less than J and I is greater than J, then it would go to the next if statement, else if. And it says it right here. If the element in array 2 is less than the element, if the element in array 2 at index J is less than the element at array 1 at index I, then we want to do the same thing that we did, but instead of inputting the element of array 1, we want to input the element of array 2 inside of array 3 at index C, because remember, we're incrementing array 3 every time, which means it's going to place the lowest value and then keep traversing through the newly created array for array 3. Now, this while loop only continues until, remember what we spoke about, until I is less than its length and J is less than its length. So what does that actually mean? So we know I and J both start at 0. So let's say I equals 0, right? So it's going to continue to cycle through this while loop until I is less than length, which was 5. So what does that mean? So it's going to traverse at 0. It's going to go at 1, at 2, at 3, and at 4. Now, since it says less than, it doesn't say less than or equal to, it's not going to traverse anymore. And also, likewise with J, it's going to go from 0 to 1 to 2 to 3. And once both of those aren't true anymore, once this isn't true and it's false, it kicks us out of the while loop. And what that means is we have a remainder. We have either I or J, I don't know which one, that's going to have a remainder inside of its array that we still have to put inside of array 3. And we have to account for that. So after the while loop, we go down here and we create a for loop. And after the while loop, it goes down to this for loop. And the conditions are if I is less than length, right? So it's looking for if I is still, like, let's say I was 3. If I was less than its length, then it would go into this for loop. If I is less than 4, it would go into this for loop. However, if I was 5, then it wouldn't go into this for loop. And that's what this accounts for. So one of these indexes, one of these arrays is going to have a remainder, and it's going to either enter the first for loop. And what this is going to do is just going to iterate through however many more elements that is left, and it's going to input it at the end of array 3. Because we know since this is a sorted array, all of the elements that are remaining are going to be the ones in order that are the least. And then after that, all we do is we return the pointer for array 3, and that's it. And you remember, this is actually returning an address, right? So we want to store it inside of a pointer. Let's review all 3 of these arrays. Okay, so this is array 1, and the values are 0, 20, 50, 80, and 100. Here is array 2. 10, 30, 60, 90, 101. And I'll actually scroll up so you can kind of see that here too. And here is the outcome of our merge to sorted array. So we have 0, 10, 20, 30, 50, 60, 80, 90, 100, and 101. So mission accomplished. That's awesome. Let's try to do, instead of the bottom one being 101, let's make this one a little less. Let's go 99. Array number 1, 0, 20, 50, 80, 100. Here's array 2, 10, 30, 60, 90, and 99. We switched it. And here is our merge function. And it looks like still correct. 0, 10, 20, 30, 50, 60, 80, 90, 99, and 100. Thank you very much for watching, and have a great day.